Okay, the last section is called related rates. And this is also on the AP test. The good thing about this one is it's two variables that you can work with. Okay, here we go. 5.6 related rates, which are called motion problems on the AP test. You need to figure out what is moving or changing or what's staying the same or constant. So we keep 2 or 3 or more variables in related rates and we solve by implicit differentiation. So in part 1, they ask you to find dt, but before I do that, I like to change this to x squared plus y squared raised to the 1/2 power. Now if I find the derivative of that, I'm going to use the chain rule. Put the 1/2, leave the inside alone, change this to the negative 1/2, and then you also have to find the derivative of both of these. Okay, so the derivative of x squared is 2x, and then now you have to remember dx dt on these, plus the derivative of y squared is dy dt. Because if you look at the derivative, it's not in terms of x or y, so you have to find the derivative of both of them. Okay, the next one. An equation with 2 or more variables that are differentiable functions of time can be used to find an equation that relates their rates, and that's why it's called related rates. Okay, so for this one, assume radius and height are differentiable functions of time and let v be the volume. Find the equations that relates dv dt and dr dt and dh dt, which means r and h, they're both changing. So v prime is equal to pi over 3. You could treat this as, if they're both changing, this is u and this is v. So I'm going to use the product rule. So I'm going to say u times the derivative of h, and the derivative of h is 1 dh dt, plus v, which is h, times the derivative of pi over 3, which is 2 pi over 3, r dr dt. Okay, the next part. This is kind of, this was supposed to be 2 pi rh. Area is equal to 8r squared plus 2 pi rh. So now we're going to go through what's changing and what's not changing. So we're supposed to find dA dt. Do you see that? They're all dA dt. All of them are. And you have to look when r is constant, when h is constant, or when neither of them are constants. How do you go about solving these problems today? So we're going to find dA dt, or a prime, same thing as this. But r is constant. So if r is constant, that means it never changes. This would make this just a number, and the derivative of a number is 0. And r is a constant again, so that doesn't ever change. So you're going to have 2 pi r dh dt. And that's the final answer without the 0. Okay, the next one, a prime, is if h is the constant one. So if h is the constant one, then you have to find the derivative of 8r squared, which is 16r dr dt, plus the 2 and the pi and the h are all numbers, they're constant. And then you take the derivative of r, which is 1 dr dt. Okay, now what happens? If they're both changing, neither of them are constant, a prime is equal to 16r dr dt plus, okay, so I found the derivative of the first one because r was changing, and now I have to do this being the u and this being the v, so 2 pi rh. So 2 pi r is the u and the v is the h. So you're going to put 2 pi r is the u, derivative of h is dh dt, h times the derivative of u, which is 2 pi dr dt. So I gave you one scenario of each of them. Okay, the next page, you just have to know how to solve related rates. I like to draw a picture and name the variables and the constants. Write down the numerical information in terms of symbols. Write down what we are asked to find, and write the equation that relates to the variables. So here we go. We have 3 problems left. So you have a hot air balloon. So I'm just going to make a cute little hot air balloon. There's my hot air balloon. She's waving. And a hot air balloon is rising straight up from a field. So it's rising straight up from the field. It's tracked by a rangefinder 500 feet from the liftoff. So that's the liftoff, and there's a rangefinder right here. And it's 500 feet away from that. At that moment, the rangefinder's elevation's angle is 45 degrees, or pi over 4. So this makes this a 90-degree angle. The angle is increasing at the rate, so this angle is increasing at the rate, so the angle, d theta dt, is equal to 0.14 radians. How fast is the balloon rising at that moment? How fast is it rising? So make this y, and you're trying to find how fast the balloon is rising. Do you see that the height is changing? So if the height is changing, we're trying to find dy dt. This is what we're trying to find, is the height. So step number 1, I've got my picture. This is step number 1. Step number 2, I'm just going to write down that I know my angle is pi over 4. That's my theta. I know my change in my angle is 0.14. I know that x equals 500 feet. This is in radians per minute. My y, I don't know why, but we are trying to find dy dt. This is what we're trying to find. So you have to think about what kind of a formula you need to use, step number 3. And I'm going to use the tangent of 45 degrees, or the tangent of the angle at that instant. You can't put in pi over 4 because pi over 4 is constantly changing, so you can't put in pi over 4. You have to do the tangent of theta is opposite y over the adjacent, which is 500. Okay, now that you have step 3 done, I'm going to get y alone. So 500 tangent of theta equals y. Step number 4, I'm going to find, the directions say to find dy dt, so I'm trying to find y prime, so I'm going to take the derivative of this. So 500 is just a constant, so I copy it down. The derivative of tangent is secant squared theta, whoops, I get myself a little bit more room. 500, the derivative of tangent theta is secant squared theta d theta dt. Don't forget that part. So you're just going to fill in 500 secant of theta, whoops, and theta is pi over 4. At that moment it's pi over 4, and you're going to square it, and we know that d theta dt is 0.14. So the only thing we have left to find is y prime, which is the change in the height. So you plug that all into your calculator, and you're going to get 140 feet per minute is what the height is changing by. Okay, the next one. Whoops. A police car approaches a right angle intersection from the north. So here's the police car. The sirens are up there. There's the sirens. A police car is approaching a right angle from the north, is chasing a speeding car. Here's my speeding car. And he is over here more, because he already turned the corner. Here's my speeding car. So a police car approaches a right angle intersection from the north, is chasing a speeding car that has turned at the intersection going east. When the police car is 0.6 miles north of the intersection and the car is 0.8 miles to the east of the intersection, the police determines with the radar that the distance between them and the car is increasing at a rate of 20 miles per hour. So you can just name these. It doesn't matter what variables you give it. I'm going to call this the Y, and I'm going to call this the X, because it's like the X and the Y axis. X, Y, maybe call this Z. The police car, so when the police car is 0.6 miles north of the intersection, 0.6, whoops, and the car is 0.8, the police determines with the radar that the distance between them and the car is increasing at the rate of 20 miles per hour. So dz dt is equal to 20. If the police car is moving at 60 miles an hour, that's their rate, y prime is 60. What is the speed of the car? We're trying to find dx dt. How fast is he going? Well, they don't give us the z, but we can use the Pythagorean theorem to do a squared plus b squared equals c squared to find out that the z is equal to 1. So I just took x squared plus y squared equals z squared, and got 0.6 squared plus 0.8 squared, and I got 1 for my z. Okay, so step 2 is to set up my equation. I'm going to use my x squared plus y squared equals z squared. Okay, notice that all three of them are changing. I know that they're all changing because my y and my y prime is given. My x, I'm trying to find dx dt, and my z and my dzt is given. So when I find the derivative of this, it's going to be 2x dx dt plus y squared, which is 2y dy dt, and z squared is 2z dz dt. And then what I'm going to do is I'm going to plug in place of x, I'm going to put 0.8. I don't know dx dt. In place of y, I'm going to put 0.6 and 60 and 2 times 1 times 20. And solve for dx dt, and dx dt should be 70 miles per hour is what that car is going. Okay, the last one. This is the last problem. Water runs into a conical tank at the rate, so here's a cone. Water runs into a conical tank at the rate of 9 feet per cubic minute. The tank stands point down and has a height of 10 feet. So it has a height of 10 feet and has a base radius of 5 feet. How fast is the water level rising when the water is 6 feet? So the water is already at 6 feet, and you're trying to figure out how fast the water is rising. So they give us the volume, and when you do this, you need to work it with the proportion, and you can only work with one variable to do this one. So I'm going to go R is to H as R is to H. So I'm going to set up, do you see that there's a littler cone down here? So I'm going to go R is to H as R is to H. And you're going to solve a tank or a can problem like this. You're going to do R is to H as R is to H. You're going to go 5 is to 10 as R is to H. We already know the height of the cone and we know the radius of the cone, but we cannot put 6 in there because 6 is changing because the water level is rising, so I cannot put 6 in there. 10R equals 5H. R is equal to 1/2 H. Okay, once I got that, I'm going to use this equation, and I'm going to come over here and say volume is equal to 1/3 pi. I'm going to replace the r, but I'm going to square it. So 1/2 times 1/2 is 1/4 h squared times h. So this stands for r squared. All I did was square it. So volume is equal to 1/3, not 1/3, sorry, 1/12 pi h cubed. So now what we have to do, this is the rate of the volume changing. I don't want to put that in for the volume. I want to change this to dV dt is equal to 3/12 pi h squared, and don't forget your dH dt because the height is changing. Now, in place of dV dt, I can make that the 9/1/4 pi, and at that moment, the height is 6, so that's going to be 36 dH dt. 9 is equal to 9 pi dH dt. Divide both sides by 9 pi. dH dt is equal to 1/pi. Put it down here. dH is equal to 1/pi feet per minute. And if you want to write it as a decimal, it's 0.318 feet per minute. Okay, last thing I want to talk about, and then I am done with notes, is a truncated cone. A truncated cone, instead of the cone being like this, if you cut off this cone anywhere, like let's say I cut it off right here, and then you got rid of that, it still makes a cone. Like if you're eating an ice cream cone and you keep working your way down, it still makes a cone. A truncated cone looks like this. It's upside down. So I just drew the exact same picture, sorry. A truncated cone is upside down. It looks like this. This is a truncated cone. So the only difference on the test is, let's say that this is, I think that's on the last one was 10, and this is 5, and the height of the water is 6. What you have to do on the test is, if it's upside down cone, when you work out the problem, like on the last problem, it was V equals 1/3 pi r squared h, correct? And then we found V prime, and we changed it in terms of r, and we found that dV dt was 1/4 pi h squared dH dt, right? And the volume was 9, so I'm just following what we just did on the last one. And we're trying to find dH dt. On the test, on the last problem we used 6, but since this one's upside down, you don't use 6. You take 10, take away 6. Since it's upside down, this is only if it's upside down. The height is 4, so it would be 16. That's only if it's upside down, do you have to use that. If it's right side up, like this, you do not need it. You can just use the 6. So keep that in mind, that on the AP test, they could try to trick you and give you a truncated cone, which means upside down cone.